Already. Hey, everybody. Welcome to another episode of Math Rock Stars with TallTal. Today, we're going to be talking about modeling the distributive property. Super important skill as you navigate expressions and equations and inequalities and all the fun things. So we got to get good at this, but we need to have an understanding of what the distributive property is all about, and we can do that by modeling. Do you guys know what part of the car is always tired? The exhaust pipe. Because it's exhausted. Here's to that dad joke. Fantastic stuff. All right, rock and roll stars, here we go. All right, so today we're going to, like I said, we're going to talk about algebraic expressions, and we're going to represent them using pictorial representations, including expressions that apply the distributive property. And we're going to be talking almost completely about the distributive property today. Which means we got to do a little vocab. Let's talk about distributive property. What this means, I'm not going to go into it deep here because I want to teach it to you after this. The distributive property is about multiplying a number by a group of numbers added together is the same as doing each multiplication separately. For example, 3 times 3 plus 2 is the same thing as saying add up. If we didn't have any expressions in here or any variables in here, we would add up inside. 3 plus 2 is 5. And then we multiply 3 times 5, right? So we do this part first. Whoops, let me go back. So we would do that part first. We would say 3 plus 2, and that gave us 5. And then we multiply 3 times 5 and get 15. And what the distributive property says is we can do them separately and still get the same answer. So we could say 3 times the 3 inside and get 9. 3 times the 2 inside and get 6. And then when we add those two together, we get 15. Voila, same thing. That may be a little confusing, but we're going to dive into it via one of my friends. Her name is Oprah. So we're going to be talking about the distributive property and Oprah. And you're going to ask yourself, what in the world does Oprah Winfrey and the distributive property have to do with each other? And you may be asking yourself, who is Oprah Winfrey? Well, she's a famous daytime talk show host. She was very famous for a long, long time doing that. A super influential person in society in regards to entertainment, and she was just a legend in the world of daytime talk shows like Ellen and Kelly Clarkson now and some other people that are doing that type of work. So what does that have to do with math, you're asking? Well, let me tell you. It's the story of the car giveaway. So Oprah used to do this thing where she would a certain time of the year, she would look for people who were in need of something. Maybe they had something tragic happen in their lives. Maybe like their house burnt down, or maybe they fell in their luck because someone lost their job in their house, and she'd want to do something real nice for them. It was like the day that she would do a giveaway for them. So she would bring them in, and this one time there was a situation where this person came in, and the goal was to talk to them, let this person tell their story, and then surprise them with a new car. Oprah was going to give them a car, but that wasn't the surprise. The biggest surprise was after she did that, the audience went crazy. They were super happy. And then she looked out in the audience and she said, you get a car, and you get a car, and everybody gets a car. Oprah gave every single person in the audience a brand new car. Okay, so you could say she distributed a car to every single person in that audience. Now, let's figure out how that relates to the distributive property, okay? So let's look at Oprah as an expression. Oprah is on the outside, and the audience is inside the parentheses. And so what happened is Oprah ended up on the outside giving a car to every single person in that audience. You can see she is distributing cars one by one to everyone in that audience. Pretty cool, huh? So you can say that she distributed a car to everyone in the audience. Now, how does that connect to math? Well, in math, we will often have a value outside of a parentheses like this. And we need to figure out what to do with that. Well, Oprah distributed a car to everyone in the audience. And remember, the audience was in the parentheses because there was multiple things going on in the audience, so there's multiple things inside the parentheses. We are going to distribute a 3 to everything inside the parentheses. So imagine this is Oprah, and this is the audience. All right, we are going to distribute the 3. And when we say distribute, we mean multiply. So we're going to multiply the 3 times everything inside that parentheses. And let's do it by looking at it through a modeling aspect first, okay? So let's remember this thing called the area model, all right? Do you guys remember doing this, like 2-digit area models? If not, let's do a quick review. So let's multiply 32 times 25. And what we would do with that is we would take 30 and 2, we'd break it apart into 2 nicer numbers to multiply, and we'd take 20 and 5, and we'd break it apart into 2 nicer numbers to multiply. And then we would do that. We would say, all right, what is 20 times 30? It's 600. What is 20 times 2? It is 40. What is 5 times 30? And that's 150. And what is 5 times 2? That is 10. And what that does is that gives us 4 partial products, okay? Partial products. And you would just take all those partial products and you would add them up. And you would get the answer to 32 times 25. Remember that area model mumbo jumbo game? Well, we're going to use that when we're thinking about the distributive property. All right, so we're going to take what the value on the outside of the parentheses, and we're going to distribute it to everything inside the parentheses by multiplying. So here's our multiplication problem, 3 times x plus 7. So let's use the area model. All right, so here's our section. We're going to put the 3 over on the side, because that's the thing we're multiplying by. And then we're going to take that x plus 7 and break it into 2 parts, because that makes it easier to multiply. And then finally, we're going to find the partial products. We're going to do this in chunks. What is 3 times x? Well, if I have x and I multiply by 3, now I have 3 of those x's, so it's 3x. And what is 3 times 21? That's 20, or sorry, what is 3 times 7? Spoiler alert, it's 21. That would be 21, okay? So now we have 2 partial products, and we just need to find the final product by adding them together, okay? Adding them together, and since they were both positives, we will keep them as both positives. Pretty simple, huh? Let's do another one. So here's our area model. We take the 2, and then we break down the other 2 parts on top, and now we have some decimals and negative numbers. Nothing changes. You just use your understanding of multiplication to now say what is 2 times negative 3c. Well, you can do that on a piece of paper. If you're allowed to use a calculator to do it, you're going to find out that that is 0.6. So 2 times 0.3 is negative 6. And we want the opposite of that, so we have negative 0.6c, right? So multiplying a positive times a negative gives us a negative number. Then we're going to multiply 2 times 5. Both of those are positive, so that equals 10. So we just carry those down and we say negative 6c. The 10 was positive, so we say plus 10. There's our answer. Let's try another one. All right, now we got negative 5 times 2 plus 5n. Now these are, the reason I did this one is I just put them in a different order on the inside. That changes nothing. You just multiply them the way you see them, okay? Let's set up our area model. Let's put negative 5 on the side, and we say, what is negative 5 times 2? Well, 5 times 2 is 10. What is the opposite of 5 times 2? Negative 10. And then we say negative 5 times 5n. So negative 5, or 5 times 5 is 25. What's the opposite of negative 5 times 5? That would be negative 25. So negative 25n. And now we take those and we write them down in that order. And this time it's not plus 25. It's going to be minus 25 because that value is negative. So negative 10 minus 25. And now we finally do one with fractions. And everyone sees fractions, they're like, oh my gosh, the world is changing. We can't. Same process. Put down your area model. Put the 1/2 on the side. Put the other 2 values on the top. And if there was 3 values, if it said plus 10j plus 14 plus 7j, you would just put more and more squares there so you could distribute them throughout. All right, so what's 1/2 times negative 4, or what's 1/2 of negative 4? That would be negative 2. And what's 1/2 of 10j? That would be 5j. Okay, so then we just bring that down. Negative 2 plus 5j is our answer. And there you have the distributive property through modeling. But here's the tricky one. You're going to see this every once in a while, so pay attention. This is, I know you're like, I get it. This is a tricky one, but once you learn this little thingamabobber, it'll make more sense to you. So we have a negative sign in front of the parentheses, 2n minus 5. If you see a negative there, all right, that is the same thing as what it's saying is negative 1. So it's basically negative 1 times 2n minus 5. It's also just saying the opposite of 2n minus 5. So let's see what I mean by that. Well, we're going to go ahead and put our negative 1 over here because a negative value means negative 1. We're going to put our 2 values on top, and we're going to say, okay, what's negative 1 times 2n? That would be negative 2n. And what's negative 1 times negative 5? Well, that would be positive 5 because a negative times a negative is a positive 5. And so when we write those down, we get negative 2n plus 5. Now, remember when I said if you have the negative sign right in front of it, it also just means the opposite of? So this was positive 2n. Now we are negative 2n. This was negative 5, and now we are positive 5. That negative sign is just flipping the values of everything inside the parentheses. Flipping it to its reverse, right? Flipping it to its opposite. So if you see the negative, it's like multiplying by negative 1 or saying the opposite of everything inside. All right. Let's go ahead and fill in some blanks, y'all. When a value is touching the outside of the parentheses, it represents the what? The distributive property. Write it down. Take some note. All right, when using the distributive property, we blank everything inside the parentheses by the value touching the outside of the parentheses. We distribute it, which also means we multiply. You get a car, and you get a car, and you get a -3, and you get a -3. Use your understanding of integer multiplication to find the positive and negative values of each section of multiplication. So just make sure you're looking at, when I'm multiplying, distributing that number on the outside of the parentheses, pay attention to your rules of multiplication. Okay, so you make sure you're making it a positive or negative answer. All right, I think you guys are ready to rock and roll. What is a car's favorite type of shoes? Duh, that would be Vans.